So this is related to our last video about finding the nth term of a sequence in an arithmetic sequence. Another related question that comes up is, how do you find the sum of the first n terms? Again, n could stand for 7, finding the sum of the first 7 terms, finding the sum of the first 84 terms. So finding the sum of the first n terms in an arithmetic sequence. And so I just want to use the example that we did last time, which was 2, 8, 14, 20, 26, and so forth. All right, this was our starting point was 2, and our common difference was 6. All right, so we added 6 every time. So just a refresher, to find the nth term, we do L equals A plus n minus 1 times D, where A is the first term, D is the common difference, N is the number of the term that we're looking for, so n minus 1 is the number of jumps that we have to get from one term to the next, and L stands for the actual term that we're looking for, not the term number, but the term we're looking for. Okay, I'm reviewing that because that's important when we go to find the sum of the first n terms. Now let me just point out something. If we take this 2, 8, 14, 20, 26, that is called an arithmetic sequence. If we change it to 2 plus 8 plus 14 plus 20 plus 26 and so forth, this now becomes what's called a series. All right, when we take the terms from a sequence and we add them up, it becomes a series. So what we're looking for, so when we say this, we would say, this is the sum of the first 5 terms. Right here, we would call that the 5th term in the series. You know, and again, in mathy language, that would be S of 5, the 5th sum that when we take those 5 and add them together. Again, we're not going to worry about this notation because we're not quite that advanced yet. We're just going to say we're going to call that the sum. All right. And I want to talk for a minute about how we get the formula because it will make a little bit more sense. And that goes back a long time ago to a young boy named Carl Friedrich Gauss. All right, and Carl Friedrich Gauss was a smart kid, and he was in his math class. And the teacher was getting frustrated with all the kids because they were acting up, and he said to the boys in the class, or all, because it was a boys' school, with the hopes of just getting a couple minutes to himself, I want you to take and find the sum of the first 100 numbers, because he figured that would take them a while and he would have just a couple minutes of peace. And surprisingly, Carl Friedrich Gauss came up to the teacher just a couple minutes later and said, I have the answer. And the teacher said, it's not possible. You could not have possibly done it that quickly. And he said, I did. And sure enough, he had done it. And here is what he had done. And we're just going to do it for the first 10 numbers just to save time here, but the pattern is true for all of them. So let's say we take the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we want to add them up. Here's what Carl Friedrich Gauss noticed. He took 1 and 10 and added them together and got 11. He took 2 and 9 and added them together and got 11. He took 3 and 8 and added them together and got 11. He took 5 and 7 and added them, 4 and 7 and added them together and got 11. And then 5 and 6 and added them together and got 11. So what he noticed is if he went through like this and just kept pairing them up, they always came up to the same sum. This was 11, 11, 11, 11, and 11. So he found out that all he had to do to find that sum of all those numbers was to find out what that pairing was and then add up how many of them he got. All right, so he found out here that the sum was 11 and that there would be 5 of them because he could make 5 pairings. All right, so the same would be true if we could take the numbers 1, 2, 3, 4, and so forth until we got up to 90, let's go backwards here, 100, 99, 98, 97, 98, 99, and 100. All right, so if he did that, he would get 101 is 101, 99 and 2 is 101, 98 and 3 is 101, 4 and 97 is 101. So he'd have all these 101s. How many of them? Well, half as many as there were numbers here. So there were 100 numbers here, and so he's going to have 50 of them. So the sum would be 50 times 101, which gives us 5,050, if I'm correct there. 5,000, yeah, 5,050. All right, so that's how he was able to compute it so quickly. All right, so basically what he did was he found the sum of the first and the last. All right, so we call the first one A, and the last one, I remember from our last video, we called that L. He found out their sum, and then he had to multiply it by how many terms there were, right, and which we're going to call N is the number of terms, and there were half as many, right? So it's half as many terms as there were times the sum of the first and the last, right? And that is the sum that we're going to be looking for, all right? Now, you might ask, well, what happens if there were an odd number of numbers in there? The formula still works. Like, let's say we wanted to find the sum of the first 9 numbers. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. We would still do this. We would get 10. We would do this and get 10. We would do this and get 10. We would do this and get 10 right here. And then this, we would just have that 5 right here. So we would end up still adding the first and last terms together. This time we have 9 numbers. We only get 4 right here. So essentially what we're doing is we're going 1 less than that, right? So if there were 9 numbers, we take half of 9, we get 4.5. So we take this part right here, the 4, right? And then we take that other term right here is half of this sum, half of the 10. So it ultimately ends up being the same. We add the first and the last. Really what we're doing then is we're taking half of this. This is going to get more complicated. Trust me, it still works. So we'll end up taking the sum. Let's see if I could give a good explanation as to why this still works. So instead of, well, actually, all it's doing is we're getting 4.5 times this. All right, here's 4 times it, and here's the half times it. All right, so we have 9 terms, and we take half of that. That's 4.5. So we get 1, 2, 3, 4 times it, and then half of it again, because that middle one is always going to be half of this. All right, so we get 4 times it and a half. So half of however many terms there are. So it still works. Okay, so then let's do an example. Sorry, getting some scrap paper here. Okay, so for our example, we have our term is, or our sequence is 2, 8, 14, 20, 26, and so forth. Let's find the sum of the first 57 terms. And again, I'm choosing 57 because that's what we did in the last problem. And the reason I'm choosing that is because we've already found the 57th term, right? So otherwise, we would have to do a little bit more work here. So again, let me write down the formula. The sum is half of n times a plus l. Hold on for just a second. Okay, so we find the 57th term. We did that last time, and what we found was, let me find my scrap paper from last time. Oh, the 57th term was 338. All right, and again, you can go back and watch that last video to see how we did that. But we would just use that formula that I recapped for you at the beginning, which was L equals A plus N minus 1 times D. All right, but we used that in the last video. We found that it was 338. So again, that's why I'm doing that, because I need that term in order to use this formula. All right, so it's asking me to find the sum of the first 57 terms. So it's 1/2 times the 57th, n is the 57th term. It's the number of the term we're looking for. So we're going to put a 57 in here. And then the first term, which was a 2, and the last term, which was a 338. Okay. Order of operations says do what's in the parentheses first. So we're going to have 1/2 times 57. 338 times 2 is 340. Now, you might look at this and say, oh my gosh, I don't want to do half of 57. It's okay, you don't have to, because remember, multiplication is commutative, and so I can reverse these two right here, or I could reverse these two right here. So how about I just reverse these two? So I'm going to write this as 1/2 times 340 times 57. And again, I'm using that dot for multiplication. We've talked about that in class before. So I'm just reversing these two, and now it's very easy for me to take half of 340. You don't even have to do that step. You can just say multiplication is commutative, and I'm allowed to do that, and just do those two together first. So half of 340 would be 170. And then times this 57. Again, I'm grouping these two together. I'm associating them and multiplying. I get 170 times 57. And then I'm going to do that work over here. 170 times 57. 0, 9, 11, 0, 0, 5, 8. So it should be 9,690 is the sum of the first 57 terms. And that would be the answer. Again, there's another problem like this in your workbook on page 74. It's problem 6. So if you'd like to practice, go ahead and do that. All right, good luck.